The week previous, what we were talking about is, do the points lie on the equation? Now, you can definitely graph the function out. I mean, if I had x plus 4, I know I can graph that thing out, but I don't really want to. I just know that this is my x value. Oops, I better turn my marker on here. I know that this is my x value and this is my y value. So if I put 0 in for x, do I get 2 out for y? So I put 0 in here, the square root of 0 plus 4. So 0 plus 4 is 4, the square root of 4 is 2. Oh, that does work. So this is a yes. Does this point lie on this graph? It sure does. How about 5, 3? So if I put 5 in here, 5 plus 4 is 9. The square root of 9 is, it absolutely works for that one also. So that's all I'm doing is I'm just plugging a point in, putting the x value in, seeing if it comes out as my y value. So if I put in 1 for this one here, 5 minus 1 is 4. The square root of 4 is 2. Boy, they all seem to work. I'm going to put a yes there. If I put 5 in here, 5 minus 5 is 0. The square root of 0 is 0. That is a yes also. I think all points work, right? No, they can't. Let's put 2 in here. 2 squared is 4. Minus 3 times 2 is 6 plus 2. So 4 minus 6 is negative 2. Negative 2 plus... that one works. Holy cow, they all work. How about this one? Negative 2 squared. Negative 2 squared is positive 4. Minus 3 times negative 2, that's negative 6. So that's going to be plus plus. Plus 2, so that's 10 plus 2, that's 12. Oh, that one does not work because they say it's 8. So this is a no. That's the only one that comes out to be a no. All right, so plugging points in hopefully didn't cause too many problems last week. Identify the x and y intercepts of the graph. Now, if it's graphed out, it's so easy. This is my x-axis, so here, 3 crosses at 9 is my y-intercept. Here I have 2 intercepts. It looks like negative 2 and 2. It looks like a y-intercept of 16. Counted by 4, 4, 8, 12, 16. Yep. And we could also check it by, remember last week we talked about if you plug in 0 for x, so y equals 16 minus 4x squared. If I put 0 in for x, that gives me y is equal to 16. It gives me my y-intercept. If I put 0 in for y, it gives me, and we solve, it gives us our x-intercept. But if they're graphed out already, all we have to do is just look at the graph and find it out. Or we could put it into Desmos calculator and find our x and y intercepts also. Now this week we're going to be talking about linear equations in one variable. That's section 1.2 and 1.3, modeling with linear equations. Section 1.2. Identify different types of equations, solve linear equations in one variable, solve rational equations that lead to linear equations. Well, what the heck does that mean? That means if you had something like x over 2 plus 4 equals 3/4. Okay, this is a rational equation, and we can rewrite it as a linear equation. The thing I always do is I always multiply every term by the lowest common denominator, and 4 would be it. So I would multiply this term by 4, this to 4, and this term by 4. Well, why do I do that? Well, if you take a look here, this becomes 2x plus 16 is equal to 3. This equation is exactly the same as this equation. I just got rid of the denominators, and you'd be surprised at how many kids, they keep the fractions in there, and it's like they have a whole page of work, and it's like, no, why are you doing that? Multiply through by the lowest common denominator, and what happens is the denominators just go away, and you're just left with a regular equation, a linear equation that you should be able to solve with no problems. Okay, that is how I'm going to teach it in this lesson. All right, equations and solutions of equations. An equation in x is a statement that two algebraic expressions are equal. For example, 3x minus 5 equals 7. We don't know what x is, but we know that we have to find a value of x that the left-hand side and the right-hand side would be equal. X squared minus x minus 6 equals 0. That is an equation. The square root of 2x equals 4. Another equation. And we'll be solving all different types of equations this year. We'll be solving quadratic. We'll be solving exponential. We'll be solving logarithmic. Just happens that this week we're just going to be solving linear ones. To solve an equation in x means to find all values of x for which the equation is true. Such values are called solutions. Equations and solutions. For instance, x equals 4 is a solution of the equation 3x minus 5 equals 7 because if I plug 4 in, 3 times 4 minus 5 is equal to 7. It makes the statement true. So 4 is a solution. Now, some problems have more than one solution. For example, the second one, the rational numbers x squared equals 10 has no solutions. There is no rational number whose square root is 10. However, in the set of real numbers, the equation has two solutions. X equals the square root of 10 and x equals negative the square root of 10. Remember, anytime you take the square root of both sides, you have to go plus or minus. So that would be plus or minus the square root of 10. All right. Hopefully this is bringing back things from years past. Some of you are like, no, I don't want to remember this stuff. An equation that is true for every real number in the domain of the variable is called an identity. For example, x squared minus 9 equals x plus 3x minus 3 is an identity because it is a true statement for any real value of x. Okay, so you could solve this thing. Any number that you put in there is going to, why? Because this side, if you multiply this out, this is x squared minus 9 on the left. If you multiply this out, you get x squared minus 9 on that side. So if you cross everything out, there's going to be nothing left. There's going to be 0 equals 0, which is a true statement. That means that all real numbers, any number that I put in here, will work. Okay, so if I put a 4 in here, I put a 4 in here and a 4 in here, I'll get the exact same thing on both sides. Every number that you put in there is a solution to that problem. An equation that is true for just some, but not all, the real numbers in the domain of the variables is called a conditional equation. For example, the equation x squared minus 9 equals 0 is a conditional equation because it only has two solutions, positive 3 and negative 3. Those are the only two numbers that will ever work in that problem. So it is called the conditional equation. Linear equations in one variable. Ax plus b equals 0 is the one linear equation you're used to seeing. It's in slope-intercept form. We can solve this problem, and linear equations are going to have one solution at most, or they will have one solution. Okay. An equation can be transformed into equivalent equation by one or more of the following steps. This is basically how we solve equations. We can add, we can subtract, we can multiply, or we can divide to solve. So if I gave you the problem 2x minus 4, let's put that over here. 2x minus 4 equals 10, and I asked you to solve this problem. Hopefully most of you remember that we would add 4 to both sides. Whatever you do on one side, you have to do the other. So 2x equals 14. Then we would divide through by 2, and we'd get x equals 7. And that would be my solution. This is a linear equation. A linear equation, how can we tell if it's a linear equation? Well, if the x value is to the first power, it is a linear equation. Here are some equations that we should be able to solve. If I add 6 to both sides, I get 3x equals 6, x equals 2. Now, when you show your work, I will need to see this. Now, some of you are going to say, Mr. Shaylin, I can do this in my head. This is easy stuff. I know most of you can. I mean, there's no question about it. But I do need to see your work. So please make sure you show your work in all the problems. In this problem here, usually when I have two variables, one variable on one side, they're the same variable, but on opposite sides is equal sign, my first step is always get them on the same. So I would subtract 3x from both sides. That would give me 2x plus 4 is equal to negative 8. Now it's a regular two-step equation. I'm going to subtract 4 from both sides. 2x equals negative 12. Divide by 2. I get x equals negative 6. And you can check yourself by plugging the answer back in, seeing if it works. If it does, you solved it correctly. If it doesn't, you made a mistake someplace along the line. Rational equations that lead to linear equations. Ooh, that sounds a little bit tougher. A rational equation that leads to a linear equation. A rational equation is an equation that involves one or more fractional expressions. To solve a rational equation, find the least common denominator of all the terms and multiply every term by the lowest common denominator. Why do we do that? Well, it gets rid of the denominator. It gets rid of all the fractions. And it just becomes a regular equation. This process will clear the original equation of fractions and produce a similar equation to work with. For example, if I had x over 3 plus 3x over 4 is equal to, the lowest common denominator between 3 and 4 is 12. I'm going to multiply every single term. Now remember, you can't just pick and choose which term you're going to multiply. You have to multiply everyone. So I'm going to multiply this by 12, this by 12, and this by 12. So if I add 12 and 3, that's going to break down to 4. So I'm left with 4x plus 12 and 4. So I can simplify that. So that gives me 3 times 3x, which is 9x, is equal to 2 times 12, which is 24. This equation right here is exactly the same as the original equation that we started with, except it has no denominators, which makes it way easier to solve. So now if I'm going to finish solving, I'm going to combine like terms. So this gives me 13x is equal to 24. Divide through by 13. And I end up with x equals 24 over 13. Oh no, Mr. Danglin, there's a fraction for an answer. Yes, you guys are in pre-college. You can have fraction answers. Could you change it to a decimal? You absolutely could change it to a decimal. I wouldn't, some kids are going to say, but Mr. Hankin, can I just rewrite this as 0.33x plus 0.75x is equal to 2? I wouldn't do that because now you're rounding values like x over 3. I mean, is it 0.33? Yeah, it's 0.3333333333. So it continues on. Is it I suppose it is okay to do that, but I would highly recommend not doing that. To just come up with, multiply through by the lowest common denominator and then solve the problem. I think the easiest way of doing it, I would highly encourage you to do it that way. All right. When multiplying or dividing an equation by a variable expression, it is possible to introduce an extraneous solution that does not satisfy the original equation. Okay, so sometimes you're going to have to put your answer back in and see if it works. Solve. Okay, now remember, anytime you see a practice in red with a yellow background, that means this problem is on your week 3 practice this week, okay? So let's solve it. X minus 5x equals 6. I'm going to subtract 8 from both sides. So I end up with negative 5x equals negative 2. Divide through by negative 5. I end up with x equals 2/5. Remember, a negative and negative is positive, so I end up with just positive 2/5. I'm going to go with the letter C for my answer. Okay. Solve these and check your solution. Oh, okay. Now, when it says check your solution, usually when I do a multiple choice question and I get the same answer, or if I get an answer that's down at the bottom, I usually think I did the problem right, and I never go back and check it. And a little cocky there, but this is the way I am. All right, so I'm thinking about, I've got 10, 2, and 20. I really have a 4 over 1 here, don't I? So I'm going to multiply every single term by 20. This by 20, this by 20, this by 20, this by 20. So every term by 20. Well, 20 and 10, that breaks down to a 2. So I've got 2x minus, well, 20 and 2 breaks down to a 10. So this is going to be 10x is equal to, well, 4 times 20, that's 80. Plus, and then let's cross out here, 4x. This equation right here is the exact same equation as this one right here. However, the equation on the right-hand side is so much easier to look at. I mean, there's no fractions in there. So now my next step, I'm going to combine like terms. That gives me negative 8x equals 80 plus 4x. I want to get the variables on the same side, so I'm going to subtract 4x from both sides. So I've got negative 12x equals 80. I'm going to divide through by negative 12. So I end up with x equals 80 over negative 12. All right. There's only one answer that has a negative in it. So I'm thinking it's B, but I'm not 100% sure. So let's simplify. 2 goes into 84 times. 2 goes into negative 12, negative 6 times. Well, that doesn't go down. So I'm going to go again. So 2 goes into 40 20 times. 2 goes into -6, -3 times. So 20 over -3. Woo! I'm going to say that's my answer. Just because it looks right. All right. Let's take a look at using mathematical models. In this section, you will use algebra to solve problems that occur in real-life situations. The process of translating phrases or sentences into algebraic expressions or equations is called mathematical modeling. A good approach to mathematical modeling is to use 2 stages. Begin by using the verbal description of the problem to form a verbal model. Now, this is solving word problems, right? We gotta read the problem, we gotta set up an equation, and then we have to solve it. This is where so many students struggle in math, is being able to solve a word problem. And hopefully by now in pre-college, you're not too bad at it. We don't have too many real difficult ones to begin the year. Then after assigning labels to the quantities in the verbal model, form a mathematical model or algebraic equation. When you are constructing a model, it is helpful to look for a hidden inequality, a statement that 2 algebraic expressions are equal. A fundamental step in writing a mathematical model to represent a real-life problem is translating keywords and phrases into algebraic expressions and equations. The following list gives several examples. Okay, so here are some keywords that we look for. For example, equality, equal. So if you're looking for an equal sign, equals, equal to, is, are, was, will be, represents. All of these words are keywords to represent an equal sign. So in this one, it says the sale price is. Oh, so I'm thinking that is an equal sign, right? The sale price S is $10 less than the list price. Oh, so here's my equation. Addition. The keywords sum plus increase by more than total. So here's an example. The sum of 5 and x. 5 plus x or x plus 5. 7 more than y. 7 plus y or y plus 7. Remember, addition, it doesn't matter if you go 5 plus 2 or 2 plus 5. They equal the same thing. Okay, so you can just flip those around. Does not matter. Subtraction. Difference, minus, less than, decreased by, subtracted from, reduced. Those are all keywords that should be key to you that it's a subtraction problem. The difference of 4 and b. 3 less than z. Now remember, this is not true. 5 minus 2 does not equal 2 minus 5. So you have to make sure you put them in order. Okay, if you don't, it really messes things up with subtraction. Multiplication, we have product, multiply by, twice, times, percent of. Those are all keywords that, hey, you're dealing with a multiplication type problem. 2 times x, 3% of t. And here's your algebraic expression. Division, keywords are quotient, divided by, ratio, per. Those are all keywords that you're dealing with the division problem. The ratio of x to 8. Okay, so those are all things that you should be looking for. Common formulas that you need to know in this class. Here they are. These are some common ones. Square, rectangle, circle, triangle, cube. If you don't know these formulas, area perimeter, area circumference, you might want to write them down because we're going to be using, I'm just assuming that you guys know this stuff already. So I'll be putting problems dealing with circles and squares and volumes and stuff like that on all the assessments. So make sure that you know these. If you don't, please copy down. You just take most of you are smart enough, you just take a snapshot of the screen and then put it into your notes. Notes? We have to take notes? Let's talk about notes. Notes are probably pretty important for most classes, and math is not an exception. Now, for assessments, let's say you take an assessment 2 times and you don't get the grade that you want. Then you have to send me your notes for the lesson. And, a lot of students, they'll just follow along. Like some of the things that were important this week were Common formula. There's not a lot this week, I don't think, but some of the common formulas. What is an equation? How do you solve an equation? Those are all things that should be in your notes. But a lot of you probably know all of this stuff already, so I don't think you're gonna need to send me your notes. Here's some common formulas. Now, I will tell you, I don't have these memorized. I mean, formula and Celsius, no way. If I needed them, guess what? There's a thing called the internet that I could just say, what is the formula for Fahrenheit or Celsius? I've never come into a situation where in my lifetime I needed to know that, where I could have just looked it up. And some of you are going to say, well, Mr. Chang, I could do the same thing with a circle, a square, and all that. And you're absolutely right. The internet is just an amazing tool that you should know how to use. All right. Formulas. Now here it says, write an algebraic expression for the verbal description. And this is another practice problem. The distance traveled in T hours by car traveling 53 miles per hour. 53 miles per hour, distance traveled, okay, in T hours. So I would go D is equal to 53 times T, because if I drove 2 hours, 53 times 106, that means my distance would be 106 miles. So I would use 53 times T for the expression. Now, if they want an equation, then I would have had to do D is equal to 53 times T. That would be an equation. This is 53T is just an expression for the distance traveled. How about this one? Write a verbal description of the algebraic expression without using the variable T minus 5. Without using the variable. A number increased by 5? That doesn't sound right. A number decreased by 5? That sounds pretty good to me. I'm going to go with letter B. You're going to say, Mr. Chang, this is way too easy. Well, yeah, we do start off pretty easy. It does get a little bit harder as we go